We are going to be looking at Lewis dot formulas. So if you look back at the periodic table and think back to how we looked at individual Lewis dot diagrams for different elements here. If I was to draw carbon, we know carbon is in the fourth group in the periodic table. So carbon has 1, 2, 3, 4 outermost electrons. And nitrogen, if I look at nitrogen, it should have 5. 1, 2, 3, 4, and then double up for the fifth. Oxygen has 6. The halogens, fluorine, chlorine, bromine, iodine, all of those, we'll just use fluorine for an example, has 7. And hydrogen has 1. So let's look at how many electron pairs are present. Well, there aren't any pairs for carbon. Notice that these are all individual electrons, right? So there is no pairs. But if we look at that, how many single electrons are free to bond? 4 of them are. Those are all single electrons. So now let's look at nitrogen. Notice that right up here is my only electron pair present. So I have 1 electron pair, and then these 3 electrons are single. So I've got 3 electrons that want to bond. And then if we look at oxygen here, I've got how many electron pairs? Well, 1, 2. I've got 2 electron pairs and 1, 2 single electrons. So 2 electron pairs and 2 single electrons. All right, let's keep up with that trend. And I'm going to use the same green. How many singles does fluorine have? Well, just that 1. And how many pairs does fluorine have? 1, 2, 3 pairs of electrons. So 3 pairs and 1 single electron. And then we have hydrogen. Hydrogen doesn't have any pairs. It just has that 1 lone electron. So no pairs and 1 single electron. Now, we are solely looking at valence electrons, those outermost electrons that are used to build molecular compounds. Not total, we're just looking at those outermost electrons. Now, non-bonding electrons are those lone pairs. All of these pairs that are present that we highlighted are non-bonding. The bonding electrons are the lone single ones that are free to bond, and when they do bond, we represent that with a dashed line. So let's look at an example here. We're going to look at these, and we'll zero in and look at ethanol first. So here's an example of showing bonding. Let's count how many bonds there are in ethanol. So there's those, and now let's count them. There's 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 bonds. And now let's look at individual elements here. So let's look at this carbon. Carbon, as we just talked about from that last slide, has 4 valence electrons. And therefore, when we look back at this, 4 outermost electrons, so it has 4 single electrons to make bonds. So, and notice that there is 1, 2, 3, 4 bonds coming off of that because there was 1, 2, 3, 4 outermost electrons. Let's look at hydrogen. So hydrogen here, we know from the previous, has 1 outermost electron. And notice that coming off of each hydrogen is 1 bond. Coming off of this hydrogen is 1 bond. And this hydrogen is 1 bond. We can see the same is true for this carbon. There's 1, 2, 3, 4 bonds coming off of it. This oxygen from the prior slide, this guy, has 2 single electrons that will bond and 2 electron pairs. So coming back here, we know that 1, 2, 3, 4, 5, 6. Well, oxygen has 2 lone pairs, which are right here, and 2 bonds that it wants to form. 1, 2. So let's count how many outermost electrons are used to make this ethanol. Well, like we said, we have 8 bonds, right? 8 was our number that we counted. So 8 bonds is equal to, there's always 2 electrons in those bonds, right? So that's 16 electrons. Plus, we have these 2 lone pairs. 2 lone pairs. And so that's a total of 4 electrons. So ethanol, this whole compound has 20 electrons that are all taking part in this valence shell. So now I want you to go and pause and try to do these other 2 compounds, amino acids like glycine and chloroform. I want you to look at these compounds, look at these molecules. How many bonds does each atom have? Does it match its predicted pattern? Count the number of bonding pairs and non-bonding pairs. How many total electrons are present in each structure? What does this match? So take a minute, pause the recording. All right, let's look at chloroform. Chloroform, if we look at this, we have 1, 2, 3, 4 bonds here. So 4 bonds, which equates to 8 electrons. And then we also have 1, 2, 3 lone pairs. This is a rainbow color, apparently. 3 lone pairs, which also equates to 6 electrons for a total of 14 valence electrons. We know that there's more electrons, but 14 valence electrons. All right, now let's look at our amino acid over here. And I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 bonds, which equates to 20 electrons. And then let's look at our lone pairs. And we've got 1, 2, 3, 4, 5 lone pairs, which equates to 10 electrons for a total of 30 electrons. Now let's look at each element within these structures and see if everything matches up. So let's look at this main carbon right here. We know that carbon has 1, 2, 3, 4 outermost electrons. And I'm going to change color here. We know that it shows these 3 hydrogens around it. And we know that each hydrogen has 1 electron. And then we show that it is bonded to a chlorine. Let's make that a different color. Chlorine, we know, has 7. 1, 2, 3, 4, 5, 6, 7 So let's look at how this lines up. We've got 2 electrons here that want to align from a bond, 2 there, 2 there, 2 there, which matches the chloroform drawing that we have with the 3 lone pairs off of chlorine and then 4 bonds coming off of carbon attached to 3 hydrogens. Okay, so now let's double check over here with our amino acid. We've got our oxygen. We know oxygen has 1, 2, 3, 4, 5, 6. So there would be 2 lone pairs off of oxygen with 2 bonds. So we've got 2 lone pairs and 2 bonds coming off of our oxygen. Same with this oxygen. We can see 2 lone pairs and 2 bonds. A double bond is 2 bonds. So our oxygens are good. Let's look at this carbon. 1, 2, 3, 4 bonds coming off of it. This carbon, 1, 2, 3, 4 bonds. So our carbons are good. Check those off. My nitrogen we know has 1, 2, 3, 4, 5 outermost electrons, 1 lone pair, and 3 bonds. So if we look at that nitrogen, we have right here 1 lone pair and 1, 2, 3 bonds, and those 3 bonds would be coming off of there. So our nitrogen is good. Everything matches. Okay, so now we're going to look at building some molecular structures. We're going to look at this H2 here. And so let's look at how many valence electrons we get from the atoms. Well, we know that each hydrogen, looking right here, each hydrogen atom has 1 electron. And so I have 2 because it tells me H2. So I'm just going to do 1 valence electron times 2. So we should have 2 electrons. All right, so my individual ones, I'm going to have an H with a single electron and an H with a single electron. So let's show the molecules Lewis. So the molecules are putting these 2 together. So I'm just going to merge these 2 individuals. So I'm going to have an H1 hydrogen there, and I'm going to have my other hydrogen with its dot right there. And then down here, we're going to do our molecules Lewis structure. So notice that there is, the only difference between these 2 is this says it's dot structure and this just says Lewis structure. So there's no dot, which means in this one, we show the bond as 2 paired up electrons. In the Lewis structure, since the dot is missing, we show the bond as a line. I like the dot because we're able to see that, all right, we have our 1 outermost electron from the 1 hydrogen there and the other outermost electron from the other hydrogen. We can visually see it a little bit better. So it kind of helps us grasp that concept. Here we're just going to show those 2 paired up electrons as a bond. So we just show it as a dash. So how many bonds are in this molecule? There's 1 bond. How many non-bonding pairs? None. And then how many valence electrons are in this molecule? So we can see that, well, because there's 1 bond, and there's always 2 electrons in a bond, so there's 2 valence electrons in this molecule. And you can always go back and, again, this is a good checkpoint because we can double check that the number of valence electrons in the molecule is going to match the number of valence electrons for the atoms that make up that molecule. So they need to be the same. So I want you to try pausing this video and try to fill in for F2 and HF. Try to fill this in and get as far as you can. Okay, so let's look at F2 and HF. So we know that Let's look at our Lewis dots here. Fluorine has 7 outermost electrons. So let's get this guy here. 1, 2, 3, 4, 5, 6, 7. That one's kind of tricky. And let's do another F over here. 1, 2, 3, 4, 5, 6, 7. All right, so each one has 7 valence electrons. So times 2, we should have 14 electrons. Let's look at H and F. So over here I've got H, we know has 1 outermost electron, and F we just said has 7. So 1 plus 7, we should have 8 valence electrons with this molecule. All right, so now let's draw it. We've got F. I'm going to use 2 different colors for F's here so we can just see them a little bit better. Oh, that wasn't a very different color. Okay, change that up. So I've got my 7 from my 1F, and let's do 7 from the other F. So we can see right here where those single electrons of each F forms a bond. So then we can draw our Lewis structure in the box underneath of it. Where it forms that bond, we're just going to show that with our dashed line and with our lone pair electrons around each one. 1, 2, 3, 4, 5, 6. So how many bonds are in this molecule? Well, just that one bond. How many non-bonding pairs are there? Well, if we were to look at 1, 2, 3, 4, 5, 6, there are 6 non-bonding pairs, which we know that is equal to 12 electrons, right? And 1 bond is equal to 2 electrons. So how many in this total molecule? Well, 12 plus 2 is 14 electrons. And we see that this matches up here. All right, let's look at H and F. So let's look at our, we just showed our H from up above has 1 electron, and we'll use F. We just said from up above it has 1, 2, 3, 4, 5, 6, 7. So we can see right here that those unbonded electrons align to form that bond. So its structure is going to be F with 1, 2, 3, 4, 5, 6, 7, and H, boom. Now, how many bonds does this molecule have? 1 bond there. How many non-bonding? Well, we've got 1, 2, 3. So again, 1 bond is equal to 2 electrons. 3 non-bonding is equal to 6 electrons. So my number of electrons in my molecule is a total of 8 electrons. And again, this 8 matches this 8. So let's look at drawing neutral Lewis structures from the following atoms. We're going to identify non-bonding and bonding pairs, figure out what its molecular formula is, and how many valence electrons are present. So let's pair up 1 oxygen and 2 hydrogen atoms. So if we know that oxygen has 1, 2, 3, 4, 5, 6 valence electrons, and we know that hydrogen two hydrogen atoms. So one hydrogen has one valence electron and another hydrogen has another valence electron. We can see that one electron right here will want to join with that one electron, and that this one electron will want to join and bond with that electron. So now we can kind of draw it in a more organized manner, we can say. So let's take that one hydrogen electron and we'll draw our oxygen again, where I have, just like I drew over here, there, and my one oxygen, and then take my other hydrogen with its lone pair to kind of show what I did with my green lines, put it all together. And now let's look at numbers. So I've got, let's take my green here. I've got two bonds. So two bonds, which equates to 4 electrons. And I have two lone pairs, which is equal to 4 electrons. So a total of 8 electrons, outermost electrons, are involved in the forming of H2O. And again, we can see that we have two H's and one oxygen. So 2 H's and 1 oxygen. Its molecular formula is H2O. And if we were to draw it using, without using the dots, so draw it using our bonds, I would have H bonded to O. O is bonded to H. So I just replaced those, the dots with bonds. And then oxygen has 2 lone pairs. Okay, so now I want you to pause and try to pair up nitrogen with hydrogen atoms and carbon with hydrogen atoms. I didn't tell you how many, but we can figure out how many by drawing those Lewis dot diagrams and seeing how many bonds it wants to form, how many H's, and look at those outermost electrons. Okay, so let's look at our nitrogen, and we know that nitrogen has 1, 2, 3, 4, 5 outermost electrons. And then we know that each hydrogen has 1 outermost electron. So there would be a spot for this hydrogen to bond here, another one for hydrogen to bond with this lone electron, and another spot for it to join with that lone electron. So I'm going to say that my lone pair, we have 1 lone pair, and we're going to have 3 bonds. So 3 bonds, which equates to 6 electrons, 1 lone pair, which is 2 electrons, so for a total of 8 valence electrons. So now let's draw our structure. We would have nitrogen with our 3 hydrogens coming off of it and our lone pair. So my molecular formula would be N, 1 N, and 3 H's, NH3. Again, if I looked at bonding, I would have 1, 2, 3, 4, 5, 6, 7, 8 electrons, or outermost electrons. Now let's look at carbon and hydrogen. And if we look at carbon, we know carbon has 1, 2, 3, 4 outermost electrons. And again, we know hydrogen each has 1 outermost electron. So this would form a bond right there. And how many more H's would we need? Well, there's 3 more spots where carbon wants to form a bond. So we would have 1, 2, 3, 4 bonds coming off of carbon. So there would be 4 H's. So we would want to form CH4 would be our formula. And we would have 4 bonds, which is for 8 electrons, and no lone pairs. Carbon doesn't have any lone pairs. And if we were to draw the final structure, it's going to look like this, with carbon in the center and 4 bonds with hydrogen around the outside of it. This next one, we're going to look at multiple bonds, because some molecules can form double or triple bonds to make sure that all of their electrons are paired. So if we were to look at how 2 oxygen atoms bonded together, so we want to make O2, so just 2 oxygens bonded together. So let's look at oxygen's Lewis dot structure. We know that it has 1, 2, 3, 4, 5, 6. And I'm just going to do its unbonded electrons. I'm going to do in pink. And then we have our other oxygen. And I'm going to do the same 1, 2, 3, 4. And then I'm going to do its unbonded ones in orange, 5, 6. So we're just trying to get these 2 oxygens together. Again, we still need to look at electrons. How many outermost electrons does this oxygen have? Well, 1, 2, 3, 4, 5, 6, right? So we have 6 outermost electrons for that and 6 outermost for the other one. So 6 times 2, 12 electrons, 12 valence electrons is what we have to be accountable for. Now what's going to happen here is we are going to pair up this unbonded 2 electrons and this unbonded 2 electrons to give us a structure that's going to be oxygen double bonded with those 2 lone pairs, and this oxygen is going to have its 2 lone pairs. If I wanted to draw the dot diagram, it would look like my 2 oxygens. I'm going to show my, what did I use? Pink, 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 and I think I used orange, but we're just kind of doing this here. And then 1, 2, 3, 4, 1, 2, 3, 4. Okay, so this is going to show our 2 sets of lone pairs on each oxygen, and then those single electrons here, these 2 and these 2 are going to align to form the double bond. So if we count our electrons, we still have 2 bonds. So 2 bonds is equal to 4 electrons. And we have 1, 2, 3, 4 lone pairs. 4 pairs is equal to 8 electrons. So 8 plus 4 is 12 total electrons, just like what we started with. So why don't you pause and see what it would look like for 2 nitrogen atoms to bond together. And again, count the non-bonding and bonding pairs. What would its formula be? Double check to see what that would look like. Then try this one. How would 1 C, 1 N, and 1 H bond together? So try those and then we'll talk about it. All right, if we were to look at nitrogen, we know that nitrogen has 1, 2, 3, 4, 5 outermost electrons. So this nitrogen would be 1, 2, 3, 4, 5. And what we'll see is that these two, and these two will want to form that triple bond. So if I look at outermost electrons, we know that each N has 1, 2, 3, 4, 5 outermost electrons, and there's 2 N's, so we're going to have 10 electrons to account for. We're going to have our each N has the lone pair on its sides, and then they're going to form this 1, 2, 3, 1, 2, 3, where, let's see if I can show these here. 1, 2, 3 will want to form together, and then it's going to end up looking like this. N triple bond N lone pairs. So if we look at counting for all of the bonds, we have 3 bonds, those 3 bonds, so 3 bonds accounts for 6 electrons, and then we have our 2 lone pairs, which accounts for 2 pairs is 4 electrons, so 6 plus 4, we've got 10 electrons. And let's try drawing these guys. So let's look at my carbon. We know carbon has 4. Look at nitrogen. We know nitrogen has 5. And we know hydrogen has 1. So let's look at our total electrons here. We're going to have 4 from carbon plus 5 from nitrogen plus 1. So a total of 10 electrons that we need to account for when we're drawing the structure. So what I would do to start is I would look at this and see, well, who needs the most bonds? And if I'm looking at this, carbon needs to make 4 bonds. Nitrogen needs to make 3, and hydrogen only needs to make 1. So I would put carbon in the middle because it needs the most bonds. So I'm just going to redraw this real quick. So this helps us kind of see a little bit easier how these bonds are going to form. And again, we can see with carbon being in the center, what's nice about carbon is it can form so many bonds. It's really a building block, for which explains why it's essential for life and why it's in so many organic compounds, because so many things can bond to it. So we can do this. We can have my hydrogen bond to carbon there, and then we can see that there are 3 electrons in carbon that need to be bonded and 3 in nitrogen. So we can just do this, 1, 2, 3. And then when we go and we write our compound out, we can see that I'm going to have H to C to N. And when I draw my N's, 1, 2, 3 with its lone pair. With my carbons, 1, 2, 3, and then my hydrogens. So this is how my dot diagram is going to look, which is then going to show us how that forms that triple bond. So if I draw this out, I'm going to have H bonded to C, which is triple bonded to N with its lone pair. Now let's count and make sure that we have the correct number of electrons. Again, we need to have 10. So I've got 1, 2, 3, 4 bonds. 4 bonds equals 8 electrons. And I have my 1 lone pair. So 1 pair equals 2 electrons. And so 8 plus 2 is 10 electrons, which matches what I originally started with. All right, so now I want you to take some time and go through and try to do some practice problems. Take a look at these different structures. Try to draw them out, the Lewis structure for them. Look at the bonding and the non-bonding pairs. Count the valence electrons. And don't just Google them and just get the answers, because you really need to know how to do this. And this is what the your turn is going to be based on. So take some time and go do some practice with this.